Hello, we are entering the topic production scheduling. We discussed planning and inventory so far, and we are entering now the production sites itself, so where we really assemble the products. And if we look on the planning and then the link to the execution layer, we have had this planning matrix, and you can see there that the detailed scheduling is one part of the production, and this is really the link towards the assembly production or the shop floor coordination. And the scheduling itself can be either done by the planning departments or it's handed to the production departments and they are doing the detailed scheduling or even the shop floor coordination. So what precisely is detailed scheduling? Because this is for sure a very, very good analytics case and a classical thing also for operation research lectures, all about optimization algorithms. So what is it? So here we can see a typical production schedule. On the left side, you see maybe different production stages. So this is here in case example of the link which is provided here. So they have a dispensing, blending, drying, coating, packaging. So that would be a typically assembly line, I think, for pharma or a process industry. And what you can see that you have maybe different dispensers A and B. So that means you have different choices how to perform the job. And typically you have different products to produce. These are the color codes here. So you have here different products like ibuprofen and ketoprofen and so on. And these are the products. And when you produce something between two different stages, you have maybe standing times. This is a black color code. So this affects your overall time or your time duration of the scheduling. And typically you have you need to allocate your resources as good as possible to meet the timelines for the manufacturing goods. So it means you promise to your customer, for example, you produce 1,000 of this type and you will deliver at this date. And then you have the challenge that you have many products, and finally you have to really optimize the sequence of your production steps. And this is really production scheduling or sometimes called fine planning. And if you look on the topics, what we have here, you have a lot of constraints to solve this optimization challenge. So for example, one of the biggest thing or as an input is the order completion time. So when do you have to deliver your product? Then you have something like a setup time. So how long do you need really to set up your resources that they are production ready? You have some resources constraints, some resources only can fulfill certain capacities, some resources cannot deliver on all products. And then you have what is of course also as important is the workforce itself. So are you really operating in different shift constraints? So for example, typically some products or some companies produce in 2 or 3 shift mode. 2 shift would be 2 times 8 hours, would be not the full day. 3 shift hours would be 3 times 8, it's 24 hours. So you're producing all over the clock, but then you need the resources. And sometimes you have constraints of the skills, because not every worker, not everybody can work on on different machines. So you have a skills challenge or a constraint. Then you have the processing time. How long do you really produce? Then you have a planned downtime. That's maybe a scheduling of something, and you really have to orchestrate everything around your planned downtime. And finally, the changeover time. So if you really switch between products, sometimes you need special cleanings or special preparations for your resources. And these are all constraints. And sometimes you even have more constraints. And this enters, of course, wonderful optimization problems, because number one, you need all the data to really formalize your problem. And you need good data quality to perform this production scheduling. And on the other side, you need the algorithms in the background to solve these optimization problems. So, and you have maybe also different targets in production scheduling. Maybe you want to optimize for the changeover is minimized, or maybe you want to optimize towards the make span. Make span is the overall duration, and maybe the changeover time is how often you really change between the products. So on the left side, you can see that at least for us in the visual context, the color codes are way better clustered than on the right side. But on the right side, we are faster with the final delivery. So how long does it really take to do it? So you have different optimization potentials, different criteria. It really depends where you have a focus on. Everything is associated to the cost, and this really determines your production scheduling overall. If we speak about this topic, and I think every lecture in operations research will discuss on scheduling algorithms, and I can only tell you that this kind of operation research tools are getting really traction also in the internet or with open source tools. And here I just have a link here towards the Google OR tools, because there you can already do something like routing, scheduling, planning, assigning, pack solve. So this kind of operation research tools are cloud services where you really pack your information in such a way and upload it to this kind of cloud service, and they will deliver you the best sequence. And this is, by the way, anyhow the future, that this kind of topics like really optimizing the scheduling are not really done by the inherent solvers of big software suites, because normally it's not the best operation research tools in the big suites. There are better solutions out there. With a big challenge, can you really access all kind of information? Can you really upload it to a SaaS service, or software as a service provider, or are the data really constrained and has to be on premise on your side? Then you have maybe other things to do. The biggest challenge for all scheduling problems is really the data quality and really defining precisely what you would like to reach. And some of these problems are really, really hard. So it's also a challenge from computational complexity. And the question is also on the rhythm, how often do you really have to rescheduling something? Because maybe something changes. For example, someone gets ill and you cannot produce it, but then you have to reschedule it maybe during the night. Or even if you're looking on the day itself, intraday, there are other topics, say one material is missing. Maybe you have to reschedule something within the day even, and then you would have to solve the problem again. Typically in shop floors, they have big manual plans, and shop floor workers are quite good then to really rescheduling on short notice. But on a big level, no human person can schedule it. Even if people think they can do it, optimized mathematical scheduler is of course the best way to do it. And there you have a lot of wonderful mathematical optimization problems to solve.